class. In the previous class we were discussing about galvanometer and different types of galvanometer. In today's class we will discuss about ammeter. We will also discuss about how an ammeter is made by using a galvanometer, and if there is a galvanometer, how it can be converted into ammeter, as well as voltmeter. So what we know is an instrument used to measure current in the circuit is an ammeter for current in the range of ampere. But if you need an instrument to measure current in lesser value, then there will be milliammeter. That you have already seen in the lab as well. It has got range from 0 to certain level. So ammeter differs in different range. So ammeter is something, instrument which is connected in series. Okay, always remember, ammeter which measures current is directly connected in series with the circuit, whereas voltmeter is something which is connected in parallel. Now, when we connect an ammeter with a series, with a circuit, what happens first of all? We know an ammeter is made up of a coil. It is an instrument after all. So it also has got a resistance. You know that every instrument, every wire has got a resistance. So ammeter has also got some resistance. So when we connect the ammeter in a circuit, the resistance of that circuit will increase, and the current which is measured by the ammeter is quite less than the current which actually is there in the circuit. Why is that so? Because resistance tend to decrease the current. So when ammeter produces resistance, the current which it is showing is actually quite less than the current which is actually present over there. So whenever an ammeter is placed in the circuit, you need to remember that the current which is shown by the ammeter is not actual current of that circuit. It is actually slightly less than that which is present in the circuit due to the resistance of the ammeter. Now, what we have to do while building an ammeter is, we have to use an ammeter of very less resistance, so that it will not create more complications, or it will not block the more amount of current. So ammeter has to be something which has very less resistance. An ideal ammeter, okay, an ideal ammeter has got zero resistance. So remember that. Ideal ammeter has zero resistance. So the current which is there in the circuit is actually what is shown in the ammeter. That is in the case of ideal resistance, whereas the resistance, the ammeter which we have, does not actually show the actual amount of current. It shows slightly less amount of current. Now, conversion of galvanometer into ammeter. Now we will discuss about how an ammeter is converted. How a galvanometer is converted into ammeter. Now to convert a galvanometer into ammeter, what we do is we connect a shunt resistance. Parallel with the galvanometer. Now we have a galvanometer in a circuit where the I amount of current is flowing. So to this circuit, we assume there is a circuit. To this circuit we connect a resistance. This is S. S stands for shunt resistance. Or I will just write shunt. Now, galvanometer and shunt is connected in parallel. So this whole setup makes an ammeter. Now, if there is parallel connection, what happens to the current? It gets divided. Suppose Ig amount of current flows through the galvanometer. What will be the current flowing through the shunt? It will be, total current is I minus the current flowing through the galvanometer. So I minus Ig is the amount of current flowing through the shunt. And at this point, this 2 will again be added. If you add these two factors, it will again become I. So this is the setup of a galvanometer converted into ammeter. Now next thing is, whenever anything is connected in parallel, current gets divided. What remains the same is the potential. So potential V is same in galvanometer G as well as in the shunt. So potential difference at these 2 points will still remain the same. So potential difference of G is equal to potential difference of S. Next, what will be the potential? Formula of potential difference, V is equal to I into R. What is I over here flowing to the galvanometer? It is I G. What is R? R is the resistance provided by the galvanometer itself, so it is G. Potential of the shunt, potential difference of the shunt. IR, I means current, okay? I just wrote down potential is equal to I into R. We are just replacing the factors over there in that equation. In place of V, we are writing IR. Now I in this shunt is I minus IG. And R is the resistance. So what is the resistance in this part? It is S. So this becomes equation number 1. Remember this, we need this equation later on also. Now from here, G will multiply this I into S minus I G into S. Now taking the IG factor on one side and IS on the other side. So IG, small g, then when we bring this side, it becomes plus, and gs is equal to is. Not small s, it is capital S. We take Ig common. What remains is G plus S is equals to I into S. Now we'll come here this over here. Ig divided by I, cross multiplication. Taking this I in the denominator, S divided by G plus S in the numerator. So this is one of the equation number 2. Now what is this Ig divided by I? So we are taking Ig out of I. So that is the current which is flowing in this part of the circuit, that is galvanometer. So this is the current, this S divided by G plus S is the amount of current flowing in the galvanometer. Okay, remember that and note it down also. That S divided by S plus G is the total current flowing in the galvanometer. Now from equation 1. So whenever we convert a galvanometer into an ammeter, what is the thing we require is, we already have a galvanometer. Galvanometer doesn't have a specific value. It is just an instrument to measure or to detect, not to measure, to detect the current. If there is current, it will deflect. If there is no current, it will move to 0. Okay. So what we have to know is S. We need to know the value of shunt in order to generate or make a ammeter. So from this equation we can get the value of S. So from equation 1, your S will be Ig divided by I minus Ig into G. So this is the amount of shunt, or the equation for the shunt, which is to be known in order to get a shunt and to make a galvanometer and convert it into ammeter. Now, few things you need to remember from this part is, now ammeter is not like galvanometer. It gives a specific range of measurement. If it is for ammeter, then it will show the current in the range of ammeter. If it is in milliammeter, then we need a different ammeter, a milliammeter device to detect the current. So now, suppose if Ig is amount, Ig gives a full deflection in the Ig gives a full deflection in the ammeter. If Ig amount of current gives a full deflection from 0, if it is up to 0 to 3, it gives a 3 deflection in the ammeter. So we actually don't know, when we have an ammeter, we actually don't know what is the current getting divided over here. What is the amount of current flowing through G, what is the current flowing through S. What we know is that I is the current which is giving the deflection. But actually what is giving the deflection? Ig is giving the deflection. It is not the I but Ig. But what we know, what we can see from outside is I is giving the deflection. Now, I'll give you a simple example to understand this better. So, what we understand this is, what will be the range of an ammeter if we have I current over there? The range of the ammeter is from 0 to I ampere. It is actually 0 to Ig, but what we can see from outside is 0 to I ampere. This will be the range of the ammeter. Now next, I'll give you a simple example for a simple calculation. Suppose remember this last equation, whatever I have written over here, that is required for the calculation. Suppose we have Ig is equals to 1 ampere. Ig is equals to 1 ampere. It means that Ig is the current which is giving the full deflection, that is 1 ampere. Now the ammeter has got a range of 0 to, it is of a range of 0 to 10 ampere. This is the range of the ammeter. So what we know is I is 10 ampere. But the deflection which is shown in the galvanometer, it is shown from 1 ampere itself. If you insert the circuit of a galvanometer having, ammeter having a range of 0 to 10, okay? You have an ammeter range of 0 to 10. Then the current which actually gives the deflection, the current which actually is giving the deflection is 1 ampere. Okay, it's only 1 ampere. But the range of the ammeter is up to 10. We actually don't know if it is 1 ampere which is giving the deflection, but what we think is 10 ampere is giving the deflection, because that is the current available in the circuit. Now, from here we can calculate the shunt. From here we can see that how much amount of current is actually flowing through the shunt. Okay. Now for that, what we know is formula of S by G is Ig divided by I minus Ig. If you put the value over here, 1 divided by 10 minus 1. This is 1 by 9. It means that 1 by 9, or the 1 by 9, the amount of current is actually flowing through the shunt. It is not going to the galvanometer, it is flowing through the shunt. What actually shunt do is, shunt actually protects the device from damage, because the extra amount of current which is there flows through the shunt, only the current which is required to show the deflection, that is 1 ampere. Only 1 ampere current flows through the galvanometer, the rest all the current flows through the shunt. So the current flowing through the shunt is 1 by 9 ampere. This is the current flowing through the shunt. But this 1 ampere can also show the deflection. Now, important points which you need to remember is, okay, the first point is the resistance of the galvanometer. First is the resistance of the ammeter. First is the resistance of the ammeter. Formula for resistance of the ammeter is, because it is connected in parallel, the formula will be this. This is the resistance of the ammeter, which is actually less than that of the shunt, because it is connected in parallel. So ultimately this resistance becomes less than that of the shunt, or less than that of the galvanometer. Second thing is, the resistance of an ammeter is very small. For ideal ammeter it is 0. I have already told you the ammeter actually has to be very less resistance, because if there is more resistance it will block the current. So we need something which does not block the current, because ammeter as a whole ammeter connects in series. It is connected in series. Now, higher the range of an ammeter, lower is the value of shunt. So, if you require a larger range of an ammeter which measures the current of suppose 1 to 100 ampere, then the value of the shunt has to be less. The value should be less. That is about ammeter. Now we'll discuss about voltmeter and how a voltmeter is made. So how to convert a galvanometer into a voltmeter? Now voltmeter is a device which is connected in parallel, okay, which is connected in parallel with the circuit, and we assume that there is very less amount of current flowing through the voltmeter. That is, we don't actually need to measure the current through the voltmeter. We only have to measure the potential difference. So what we have to do is, the resistance, what was there in ammeter was the resistance of the ammeter has to be less, so as the current can be flow easily. But in voltmeter, we don't want the current to flow through the voltmeter. We only want to measure the difference of potential. So we don't want any current to flow the voltmeter, so the resistance of the voltmeter is very high. So an ideal voltmeter has got infinite resistance. Remember this, ideal voltmeter has got infinite resistance. But there is voltmeter which we use has got finite resistance and which actually blocks the current and lets the current flow through the another part of the circuit. Because voltmeter is connected in parallel, it lets the current flow through the another wire which is present over there. So we'll discuss now about how a voltmeter is made. So conversion of a voltmeter, a galvanometer into voltmeter. So we have a wire which has got a potential of V. Now whenever we connect a voltmeter, we connect that in a parallel to this one. So this is the wire, main circuit. We have a galvanometer and we connect a resistance to that. So this part makes the voltmeter. This part only makes the voltmeter. I have drawn this part whole because this is the circuit where the voltmeter is connected. Galvanometer in series with a resistance makes voltmeter. Galvanometer in parallel with the resistance makes a ammeter. So resistance is connected in parallel with the galvanometer. Now let us move on to the calculation of the resistance. What will be the amount of resistance required over here? Now the current flowing in this part, let us think that I. Okay, current flowing in this part is Ig. We don't have to divide the current because it is in series, and in series current flows, the same amount of current flows over here. Now next one, what we will calculate this is through the equation of current itself, because from potential, the potential gets divided. So current over here is Ig. So current is equals to I is equals to, from the equation of Ohm's law, I is equals to V divided by R. I is equals to V. V is the potential over here divided by R. What is the resistance over here? Resistance is G plus R. So this is the amount of current flowing through the galvanometer or the voltmeter. Now we have to make this R very large in order to let the current not flow through the voltmeter and to flow through this resistance over here. Now next, from here we have to find the value of R. So in order to find the value of R, what do we do is, Ig is G plus R into V. Or from here what we can write is G plus R is equal to V divided by Ig, or R is equal to V divided by Ig minus G. So this is the amount of resistance required to convert a galvanometer into a voltmeter. Now for full deflection, for this the range of the galvanometer will be from 0 to V. There are few important points in regard of this. First one is resistance of voltmeter. First one is resistance of voltmeter is equals to R plus G. This is the formula of resistance of voltmeter, and it will be very much greater than the resistance of the galvanometer. The resistance of the voltmeter is very high. For an ideal voltmeter, it is infinite. I have already told you the total resistance of the voltmeter has to be very high, and for ideal, the resistance is infinite. Another one is voltmeter is connected in parallel, hence potential difference between 2 points is not changed. So the potential difference between this point and this point, suppose A and B, cannot be changed. It will be fixed for this voltmeter as well as for this one as well as for voltmeter. The potential difference should be the same. Higher is the range of voltmeter, higher will be the resistance. For a voltmeter to measure the higher potential difference, the resistance of the voltmeter will be higher. Okay, now the chapter is over with this ammeter and voltmeter. What I will do next is, there is one numerical, only one numerical from ISC section. That is question number 10. In your book, the question number might be different. Just I'll read out the question. Please listen carefully and just mark the question itself. Question is, a moving coil galvanometer has a coil of resistance 59 ohm. So for that, I'll just drop this part. Calculation is very simple. I'll give you the values and the formula. You do the calculation by yourself. For a moving coil galvanometer, the resistance is G is 59 ohm. Okay, that is the resistance of the galvanometer itself. It shows a full deflection of a current for 50 milliampere. Full deflection means Ig is equal to 50 milliampere. At 50 milliampere itself, it shows a full deflection. So, but the current in that circuit is quite higher than that which is shown. How will you convert into an ammeter of a range of 0 to 3 ampere? So the range is 0 to 3 ampere. This is the ammeter used, but the deflection is shown in this itself. So the current I is equal to 3 ampere. Okay. Now next, what I have to do is, how do we convert this galvanometer into an ammeter? How do we convert that? By connecting a shunt in parallel. Okay, we have to connect a shunt in parallel. Now the equation for a shunt, I is I divided by, Ig divided by I minus Ig. This is the equation into G. This is the formula for calculation. Now everything remains the same except for this. 50 milliampere has to be converted into ampere. That will be 550 into 10 to the power minus 3 ampere. Okay, values are given. Just put the value over here. You will get S is equals to 1. Okay, this kind of numericals are frequently repeated. You can solve from the example section also, and if you need help, please do always ask for help. Okay, this much for today. In the next class, we will be starting a new chapter. Thank you very much for today.